Hi everyone, I'm Sheila Kester, COO of TwinThread, and I'm here to talk to you about 5 keys to succeeding with industrial AI. We'll talk about the importance of the right use cases, baselining your performance, planning to put it into operation and then doing so, the importance of engaging your operators, practicing to make it perfect, and then putting it into scale. So, what are the characteristics of ideal use cases? Well, AI anywhere is about data. So the first and most important thing is that you actually have historical data available, at least 3 months, ideally more than a year, and that data needs to be good, of good quality. Second, AI is about numbers, which are about math. So you need to make sure that your metric and the outcome are well defined. Cost benefits, numerical benefits, binary yes-no benefits are all fine. AI is about reducing variation in industrial situations. So you want to make sure that you start out with a metric that has variation. So in this example, downtime is 19% plus or minus 10% month to month. You want to make sure that when this project is finished, that it will matter from a financial point of view. That will give you the necessary support to overcome the friction that asking people to change inspires, and also ensure that you have executive support. And lastly, you need the same or similar objectives across multiple plants to make sure that the work that you put in your first project has application and therefore benefit in lots of places. Here are examples of some outcomes, and again, one use case may have multiple outcomes, so this is just to get you started thinking about what you might do. Baselining says, where are we now, where do we want to go, and are there best practices? Again, how do you know that you've done what you said you would do unless you have a solid measurement of where you began? In this case, yield in our Richmond plant is substantially lower than yield in our other 2 plants. And so our use case might be to improve yield for Richmond by 20% and to then map it against the Fremont and Daly City performance. So operationalization is the process of turning what I would call the beginning stages of an AI project into something that is actionable, which in fact also involves AI. So in this case, you're not only connecting to data, determining your baseline, figuring out what the root causes are, you're then taking those root causes and allowing AI to determine that they're happening, to determine work processes that need to change as a result of these root causes, and then putting those recommendations, those fixes, into action. And I want to stress, it's only at the end that you're going to see those financial results, those economic benefits that I talked about. I can't stress enough the importance of involving your operators and your operations team at every phase. They are a critical source of expertise and credibility at every stage of your industrial AI project. At the beginning, when you're putting in something that's new, their support and confirmation that the digital twin process is capturing reality is crucial. In the next step, when you're going through your first use case, you're detecting those anomalies and you're starting to make change, you really want your operators to be able to say, you know what? I don't need my black book anymore. The system is now capturing all of those variances, all of those set point changes, formula changes, weather changes that cause me to have to refer back to my book to just understand what I have to do. No, the system's got it. And then once you're past your first project, it's about helping your operators, because in the last 5 years, it really hasn't been a great time to be an operator. There are less operators overall, and the average experience of those operators has dropped by a lot. So industrial AI is important in asking them to say, what can we do to make your job feel more doable, more interesting, more fun to you? What can we change from a process point of view? What could we digitize? So lastly, I want to talk about the difference between an innovation program and a scaling program. And you do need both to realize the economic benefits that I talked about at the very beginning. So on the left-hand side is what we call the innovation program. That's starting with your use case, your multiple use cases, and evaluating their feasibility using the criteria I shared with you, putting together a solution, which is a way to recognize, for example, anomalies, determine what types of recommendations you want to make, who you want to have react to those recommendations, and then actually deploying the solution over your first set of assets or your first production line, and just making sure it works, making sure that the theory of the case actually turns into the reality of the case, the economic benefits. And sometimes there's a loop here that goes through where you tweak and adjust and tweak and adjust. until you've got something which you can then take and scale, your viable use case. From there, you take the baseline that you learn from your innovation program and you move into a scaling program where you plan on how to take that viable use case and roll it out across multiple sites, or maybe within one plant, multiple lines or multiple assets. And again, this is an iterative process where you're constantly measuring utilization, measuring impact, planning improvement. So it's iteration in a similar manner from the innovation program that's then done at the scaling program. So that's it. Those are the 5 keys to succeeding with industrial AI that I wanted to share with you today. I hope you found it helpful, and please reach out to me on LinkedIn if you want to talk about it further. Bye.